Other libraries that you will find useful. Oh, here's one that I like. Here's a library that I think you might enjoy. Import string IO. Okay. My data equals, this is the first line, this is the second, this is the third. I hope you get the idea. Okay? So my data is one string with some embedded new lines. Right? Triple quote, triple quote, multi-line string. Suppose I want to read data from that. I can say reader equals string IO dot string IO of my data. For line in reader, print line. The string IO object, it's a class, lives in that library. What it does is say, I am going to wrap up the string with something that has all the same methods as a file. So instead of reading from a file on disk, I will read from a string in memory. So the trick I showed you this morning of taking the string and breaking it on new lines and then processing those lines, you don't actually have to do that. There is something in the Python standard library that says, all right, you happen to have put your characters in a string buffer in memory as opposed to over there on a spinning hard drive. I don't care. I will read from it as if it was a disk. Okay. So this gives you back the fidelity, the truthfulness of the testing that we sacrificed by splitting on new lines. Right. There's my test case. If I pass that reader into something that is expecting to read from an open file, it cannot tell the difference. It does not know whether read line and read lines and line in reader is reading from a string in memory or from a file on disk. And we worked very hard to make sure that you couldn't tell the difference. Okay, please.
Why is there a blank line between?
Aha! Why is there a blank line? Well, when I get lines out of a file, the string I give you includes the new line at the end, right? And when I do print, it automatically puts a new line at the end of the line. So I get one new line for the one that's embedded in the string, and I get another new line that print has put on there. So I get double-spaced output. All right? That's why this happens. Good question. Okay? So if I'm writing tests, I can use the string IO object and read from a string instead of reading from a file on disk or munging strings myself using split and stick in the list and stuff like that. Okay? I can do it the other way too. Writer equals string IO dot string IO. Create a new one. Okay. And then print to writer first. Print to writer second. Print to writer third. Oh, sorry. Print to writer third with the closing quote. Okay. Help writer. What methods does it have? Ah, good. It's called getValue. Writer.getValue. Let me get that up to the top of the screen so people in the back can see it. When I create a string IO object, I don't have to tell it whether it's in read mode or write mode. Okay. When I'm opening a file, I should tell it, am I reading or am I writing? Okay. String IO object, I don't have to tell it. But it has methods like write and write line. You can print to a string IO object. And all it does is just save all the data you've been printing. But instead of saving it to a file, it saves it to a string. So now I can go back and I can look at it and say, did I print the right stuff? But instead of printing it to the screen and having a human being eyeball it, I print it into one of these string objects. And then I just say, is the value I get back from it the string that I was supposed to write out to the screen? Right? So instead of sending my output to a screen, where a human being has to look at it and say, is this right? I do exactly what I would do if I was printing to screen, but I print it to a string, and now I've got something I can do a double equals test on. Right? So if we come back to the example from this morning, if I'm supposed to print out the names of bands and songs that will actually work, I could just print that instead of to the screen or instead of to a file. I could just print that into one of these and then say, right, is the final string the thing that I was supposed to have printed to the screen? I can make my tests more faithful to the real world scenario. I've created an object that pretends to be a file, that I can treat like a file, except it's not really a file. It exists. It was built for testing purposes. And you'll see this idea come up over and over again when you start to test your own software. Instead of writing to a real audio device, I write to something that has all of the same interface as a real audio device, but it's saving stuff so that I can compare it later to what I should have got. Instead of playing the sound, I save the waveform to a string in memory, to a file on disk, to something, so that I can then look for any differences between that and what I was expecting. Okay? You really want to be building components with well-defined interfaces, like string I/O and file, so that I can swap one out and swap the other in, and the rest of the program doesn't know. Right? A capacitor is something with two wires that can... Right? A capacitor is something with two wires that can store charge. Right? I should be able to take out any 25 microfarad capacitor and put in any other 25 microfarad capacitor, and it should still be storing the same amount of charge. Right? That works because we've got two wires, one here, right? And you don't care what's in between as long as it can store charge. You want to do the same with your programs. As long as there's a well-defined interface, right? Files know how to do read line, write line, open, close. Anything that has that same interface, anything that has those same methods, can be swapped in instead.